Hey guys, Ms. Gosling here. In this video, you're going to learn about Newton's second law. By the end of the video, you'll be able to define and give examples of Newton's second law of motion. So let's go ahead and get started. So Newton's second law is also known as F equals ma. It's often written that way. And what it says is that when a force, and of course when I say force, I mean an unbalanced outside force, as we learned about in our inertia unit, video. So when an unbalanced outside force acts on a mass, it is going to cause that mass to accelerate. So we express Newton's second law is looking at now, in our first law we talked about what happens when there are no forces acting on an object, or when those forces are balanced. In Newton's second law, we're looking at situations where the forces are now unbalanced. So when a force is changing the motion of an object. So when a force changes the motion of an object, what it will do is cause that object to accelerate. And the greater the mass of the object, the less it will accelerate. The greater the force, the more it will accelerate. So think about a toy truck versus a real truck. If I push on this toy truck with some force, and I push on the real truck with that same amount of force, because the mass of my toy truck is little and the mass of my real truck is big, my little truck, my toy truck, is going to accelerate at a much faster rate than my real truck, right? And you could think about this like if you push on a toy truck, that toy truck's going to move. If you push on a real truck, that truck is probably not going to move because the force that you're applying on it is not enough to even make it an unbalanced force. So let's look at an example. My cat, Abby, bats a 100-gram toy mouse around the floor. If she hits it with a force of 1 Newton, how much will it accelerate? So let's go ahead and solve this problem. So my givens here are my mass, which is 100 grams. Now notice we're in grams and not kilograms. I need to turn this into kilograms. And to do that, I'm going to say I know that there is 1 kilogram per 1,000 grams. So I'm going to divide by 1,000. Giving me that my mass is 0.1 kilograms. So again, key note here, your mass needs to be in kilograms. So I know my mass is 0.1 kilograms, and I know that the force that she is applying to the toy mouse is 1 Newton. So now I am ready to write out my unknowns, figure out my equation, and solve. So my unknown here is my acceleration. And the equation I'm going to use to find my acceleration is, of course, going to be my equation for force, Newton's second law, F equals ma. And now I can go ahead and I can sub and solve. So I know that my force is equal to mass times acceleration. So my 1 Newton force is equal to my 0.1 kilogram mass times my acceleration. Thus my acceleration is 1 divided by 0.1, or 10 meters per second squared. Now, one thing I want to mention here is units. So you'll notice we have a capital N here, and that is going to be the units for force. Now I also want to mention my units for force are newtons, and I know from F equals ma that my Newton is equal to the units for mass, which is kilograms, times my units for acceleration, which is meters per second squared. So 1 Newton is equal to 1 kilogram times meters divided by second squared. And this is a little bit unnecessary. It's a little bit of an extra detail, but it's also kind of useful to know because it's a way to check to see if what you're doing is correct, i.e. is your mass in kilograms, is your acceleration in meters per second squared, therefore can you use them to find force? But the key point here, guys, if you see capital N, that means force. Now, I did want to talk about one last thing before we continue, before we finish up this video, and that is mass versus weight. So mass is a quality that is inherent to an object. So think about my coffee mug, which you guys see pretty often, right? So if I take my coffee mug and I move it from the earth to the moon, my coffee mug is going to have the same mass on earth that it has on the moon because it's a quality object that will not change. However, weight is another word for the gravitational force or the force of gravity acting on an object. So because the gravitational pull of the earth is so much stronger than the moon, my weight is going to be much bigger on earth than it is on the moon. And we can actually figure out the relationship between weight and mass using another key equation for our unit. And that is that weight is equal to mass times little g. So again, weight is equal to mass times little g, which is, of course, 9.8 meters per second squared. And that is going to be another key equation that y'all are using this unit. So let's look at an example with that equation. A textbook weighs 19.6 newtons on Earth. What is its mass? So my given here is going to be, of course, 19.6. And looking at the units here, I know that that is a force, and I know that that's listed as being its weight because the question tells me that that is its weight. It says that it weighs that much. I also know that on Earth, my gravitational acceleration is 9.8 meters per second squared. And reading the question, I can tell that my unknown is my mass. Thus, I will want to use the equation W equals mg to find my mass. Now that I have my equation, I can sub and solve. So let's go ahead and do that. So I know that W, or 19.6, is equal to m, which is my variable, my unknown, times little g, which is 9.8. So I can divide both sides by 9.8. And what I'll find is that the mass of my textbook is 2 kilograms. And there you go. That is how I can go from weight to mass. Now, I will say, if I have my mass instead of my weight, I can do W equals mg, and I can use that to find my weight. Note that you'll be able to tell whether you have mass or weight by looking at your units. So if our units are kilograms, we have mass, and if our units are newtons, we have weight. So let's talk takeaways. First of all, unbalanced forces cause objects to accelerate, and weight is another name for the gravitational force. It's equal to mass times gravitational acceleration, little g. So there you have it, guys. You now know how to use Newton's second law. Best of luck and happy solving.